Hello class, and welcome to section 1.5, which is about solving inequalities with one variable. By the end of the lesson, you'll be able to solve and graph inequalities. So inequalities are math sentences that compare two quantities that are not equal. So yesterday's lesson we talked about equations, and most of chapter 1, part 1, focused on equations. Now we're shifting from when things are equal to each other to when they're not equal to each other. We have four different symbols that show us inequality. The first one over here on the left is less than. The next one is greater than. Then we have less than or equal to, then greater than or equal to. These symbols are always read from left to right. So we would say 5 is less than 7, or you could rewrite it and say 7 is greater than 5. So you always read them from left to right. And then in this chart, you will just see a few phrases for word problems that might tell you or indicate that you should be using these inequality symbols. One of the things students often ask is, how do we know the difference with less than and subtracting? If you are using an inequality symbol, it will have the word is associated with it. So it would say 5 is less than, and that would indicate that you should be using the less than sign instead of subtraction. So look for that word is to be attached to any of the phrases in the chart to tell you to use these various symbols to write out these math sentences. When you are solving inequalities, you are following the same rules as solving an equation. So we are still using SAD-MEP, aka PEMDAS backwards. So we're looking to get rid of any addition or subtraction first. So in this problem, we have plus 23, so I'm going to go ahead and subtract that 23 from both sides to get it to cancel out. So I'm left with negative 8x is less than 40. So again, just like equations, we're using SAD-MEP to solve. Then I'm going to go ahead and to get rid of that negative 8, I'm going to need to divide both sides of the equation by negative 8. Now, one thing you probably want to make note of is if you multiply or divide by a negative, you need to flip the inequality. So if you are multiplying or dividing by a negative, you need to flip the inequality. Reason being is once you get into those negative numbers, the bigger values are more negative. So negative 5, if it's positive, well, 5 is bigger than 4 on the positive side of the number line. Negative 5 is less than 4 on the negative side. So when negatives are involved, we need to make sure we flipped that inequality sign. So we end up with x, we flip the sign from less than to greater than, and we end up with negative 5. The last piece is we want to be able to put this onto a graph. One thing you might want to add to your chart is when you are graphing, less than and greater than are graphed with an open circle. Greater than or equal to and less than or equal to are graphed with a closed circle. The open circle means that number is not part of the answer. The closed circle means that it is part of the answer. So if we come back to this, we've got x is greater than negative 5. So I'm going to come over to negative 5. 1, 2, 3, 4, negative 5. I'm going to put an open circle there. Reason being, negative 5 is not greater than negative 5. Now, we need to figure out which side of this point gives us the correct answers. Personally, I like to use 0. 0 greater than negative 5. That works out. So we draw the arrow going towards 0. So your goal here is to try to find something that makes it true, and then that whole side of the inequality is going to be your answer. Go ahead and try this one on your own. We add 19 to both sides, divide by 7. There was no multiplying or dividing by a negative, so we left the inequality as it was. Filled in circle because we have a less than or equal to, and then 0 is indeed less than 7, so we are going towards zeros. All of those numbers below 7 make that inequality true. Just like you can have equations that have multiple variables show up in them, you can also have inequalities that have multiple variables show up in them. So just like we did with the equation, we want to get rid of this parentheses first. So we're going to go ahead and use the distributive property. So negative 4 times 3x is negative 12x. Negative 4 times negative 1 gives me a positive 4. Then we're adding 6x, and that's greater than or equal to 16. Since my variables are on the same side of the equation, I am just going to combine the like terms. So if I have negative 12 x's and I'm adding on 6 x's, that gets me to negative 6x plus 4 is greater than or equal to 16. Following sad meep, our next step is going to be to get rid of that 4. So we've got negative 6x is greater than or equal to 12. And we're going to finish by dividing by negative 6, which since we divided by a negative, we need to make sure we flip that sign to less than or equal to when we have our final answer of negative 2. Coming down to the graph, we go 1, 2 to the left at negative 2, filled in circle because we have that equal to part, and then all of the numbers that are less than that. So we could, for example, say negative 3 is less than or equal to negative 2, or negative 10 is less than or equal to negative 2. So all of these answers to the left of that point make that a true statement. Go ahead and try this one on your own. Again, start by doing the distributive property. Once you do that, we're combining our numbers this time because we have two numbers on the same side of the equation. Then we're going to add 2 and divide by negative 6, and this time we end up with x is greater than negative 2. So we've got that open circle, so it's not included, and then we are going to the right. Again, similar to equations, we can have problems that have variables on both sides of the inequality. Once again, our goal with this is to get it to one variable. So we're going to need to move either the 3.5x or the 1.5x. Personally, we want to try and keep them positive. So we're going to take away 1.5x from 3.5x. That's going to give me positive 2x plus 19 is greater than or equal to negative 7. Our next step, following sad meep, is going to be to get rid of that 19 by subtracting it from both sides. So I've got 2x is greater than or equal to negative 26. And then finally, I can divide both sides by 2, and I end up with x is greater than or equal to negative 13. Now when I come down here to graph, I only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. So I'm going to need to count by something else to make it fit on my graph. I'm going to go ahead and count by negative 2's. So negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, and negative 14. Negative 13 is going to fall right in between negative 12 and negative 15. So I've got a filled in circle because we have that equal to part. And then I want the numbers that are greater than that. So I am moving to the right. Go ahead and try this one on your own. We've got subtracting to get the x's together, and then adding to get rid of our numbers, and finally dividing by 3 gives us 6 is less than x. If it helps you to have your variable on the left side, you can switch it around and say x is greater than 6. Both of those are true statements. Both of those count as the same answer and have the same graph. Another thing I want to talk about is inequalities that have all solutions or no solutions. Again, this is similar to what we had with equations. This occurs when we have the same amount of variable. So if I do my distributive property here, I end up with negative 6x, and negative 3 times negative 5 is positive 15, is greater than negative 6 plus 9. Once again, I want to start by combining my variables. So I'm going to add 6x to both sides of this. When I do that, both of my variables cancel out. So I'm left with 15 is greater than 9. This is a true statement. And because it is a true statement, That means we have all solutions or infinitely many solutions. Any number that you can plug in is going to result in 15 being greater than 9, so all possible numbers work. If I come down to this bottom one, again, start by distributing. So the left side stays the same with 4x minus 5, and then after I distribute, I've got 4x minus 6. Then I'm going to go ahead and subtract 4x from both sides. When I do that, I end up with negative 5 is less than negative 6. Negative 5 is less than negative 6 is a false statement. So that is how we end up with no solution. It won't matter what number you plug in. This problem will not work out to be a true inequality. So again, if you have variables that match, so negative 6x, negative 6x, in this case it was 4x and 4x, you're going to fall into one of those two situations, either with infinitely many, if you get a true statement, or no solutions with a false statement. Go ahead and try this one on your own. We end up with a true inequality, so we have all solutions. If it asks you to graph, that means you covered the entire number line. Finally, we're going to write and solve our own inequalities. So Derek wants to order some roses online. For what number of roses is it less expensive to order from florist A? And then the second part of the question is from florist B. So first, we need to take our information about florist A and turn that into part of our inequality. So it says $4.75 per blue rose plus a $40 delivery fee. So we have $4.75 per rose plus our $40 delivery fee. The other one says we've got $5.15 for a red rose plus the $25 delivery fee. So we got $5.15 plus our $25 delivery fee. Now, we want it to be less expensive to order from florist A. Since florist A is the blue, we want that to be our less expensive. Then we're going to go ahead and solve, just like we would with all the other equations. So we're going to go ahead and combine our variables, subtracting $4.75 from both sides. And that is going to give us 40 is less than 0.4r plus 25. After that, I need to get rid of that 25. So I'm going to go ahead and subtract 25 from both sides of my equation, which gives me that 15 is less than 0.4r. I'm going to go ahead and finish by dividing by 0.4, which gives me a statement that 3.75 is less than r. Now we need to go back and look at the question and see if we have actually answered it. It says, for what number of roses is it less expensive to order from florist A? So, in order for the blue roses to be our less expensive, we need R to be greater than 37.5. The closest whole rose is 38. So for florist A, it's cheaper to buy 38 or more roses which then on the opposite side of that means for florist B, so florist B is cheaper if you buy 37 or less. Go ahead and try this one on your own. Make sure that you are paying attention to the fact that he is buying 1 tuna salad and 1 bottle of juice. So, you add on the tuna salad and the bottle of juice to your 4x, which is your pounds times your cost of potato salad, when you solve that problem, you end up with x is less than or equal to 0.875. So that means he can buy at most 7/8 pounds of potato salad, or you could say he could buy 7/8 or less. If you'd left it in decimal format, that is also okay. If you have questions about this or anything else from the lesson, please let me know when you get to class.